Welcome to Brainbox. Students, we are going to discuss now about the metals and non-metals. See, what are basically metals? See, metals, where are they arised from? See, we know this point that everything in the universe is made up of something called matter, right? And matter is made up of elements, right? So, elements, there are many different kind of elements. Now, all the elements are just broadly classified as metals and non-metals, right? So let's see the properties of metals and non-metals, and even let us compare them so that we can understand how the metals exist in the nature, how do the non-metals exist in nature. See, the properties of metals we will see. So metals are basically lustrous in nature. They are lustrous in nature. So what is this lustrous nature? Lustrous nature is basically something like showing the shining whenever some light falls on the metals. See aluminium, how it shines, and we would have seen the metals like gold, silver, who has a very good shining, right? And at the same time, if at all we see the non-metals, they are non-lustrous in nature, or they are not lustrous. But anyway, here we have a small exception, that iodine, okay, iodine is lustrous actually. So this is an exception. Like there are many non-metals we have, almost all non-metals are not lustrous in nature, but iodine, even though it is non-metal, it is lustrous in nature. And now the next case we will see that all metals are malleable. They are malleable and ductile. So what is this malleability, ductility, and how can we say that the given metals are malleable and ductile means? See, you see any metal, you can draw the given metal into very thin sheet, right? Or at least you can even draw the given metal into very thin wires. So the ability of any metal to get drawn into the thin sheets and to get drawn into the thin wires, that ability or that property, we call them as malleability and ductility. So we can say that metals are malleable and even the metals are ductile. See, you would have seen that gold, silver, these are the most malleable metals and even the most ductile metals. So it is not exception here, it is the example what I am giving, that silver, gold and silver. So gold and silver are most malleable in nature. And here the same thing, if at all we compare, they are not malleable and not even ductile also. So metals are, they are neither malleable nor ductile. So we cannot draw the non-metals into thin sheets, or we cannot even draw the non-metals into thin wires, right? So they are not malleable, not even ductile. Okay, and next, if at all we see, they are good conductors of heat and electricity. Okay, they are, means metals are basically good conductors of heat and electricity. They can conduct heat, they can even conduct the electricity. But if at all we go for metals, they are not good conductors of heat and electricity. But again here also graphite is exception. Means what does it mean? That graphite is a good conductor of electricity, right? So generally metals means they are good conductors of heat and electricity, and non-metals are not good conductors of heat and electricity. But here among the non-metals there is one element which is graphite, which is a good conductor of electricity. So it is exception, that what is in what you can find the exception, it conducts electricity, right? Now we'll go for the next, like sonorous nature. So they are sonorous in nature. In the sense, when hit by something with a strong object, when we hit the metals, they make sound. Right? I think you would have visited many temples. Whenever you visit a temple, the first thing what you will do is you will blow the bell. Right? And how you're making a sound. Right? You are just hitting that, but the same will make a much large noise. Right? And that is because that object, means the bell, is made up of metal. Right? So basically almost all metals are sonorous in nature. So they make sound when hit by certain big objects. Right? And here non-metals, if at all we see, they are not sonorous. Okay, they don't make any sound whenever we hit with the strong objects, right? And now the same thing, if at all we see that the metals, most of the time, hard solids, they are mostly hard and they are solids. Now, for the word hard or even for the word solid, we have few exceptions. Like, see, almost all metals are hard, but few metals, like example, sodium, potassium, are soft. They are not hard. Right? And all metals are solids. Exception is mercury. Mercury is a liquid. Right? Then we'll just see with the non-metals. See, most of the non-metals, either they are gases, because there are few non-metals which are solids and few non-metals which are gases. But there is a only non-metal which is bromine, is a liquid. Okay, so if at all we compare here, there are very few metals. Few metals are softer, except that if at all we leave that as an exception, remaining all metals are hard in nature, right? And mercury is not even, it means it is very soft metal, but again the basic thing is it is not the solid at all, it is the liquid. And in the whole average, means whatever may be the elements present, overall there are only two liquids. One is liquid metal, and one more is liquid non-metal. So the only liquid metal present in the all elements are in the periodic table is mercury, and the only liquid non-metal present is bromine. Okay, and few metals, like, so you can take the example of cesium and gallium. So these metals are so soft that they have very low melting point, that if you hold them in your hand, they will melt away. In the sense, for the temperature which is present in your palm, they can melt. Means the melting points of these metals are very low. Right? So these are the characteristics of or properties of metals. So mostly what do you understand from this? Almost every metal is characterized with the lustrous nature, malleable, ductile, and conductivity of heat and electricity, similarly sonorous nature. And the most of the metals are hard. And we have discussed about the exceptions here. That the exceptions are, few metals are soft, like waxy. So the soft solids or soft metals, whatever we have, you can cut them freely with a knife. Right? And similarly, mercury is a liquid. Right? So the mercury is one liquid. How we can say, means it is like it does not exist in the solid state every time. And at the same time, there are few exceptional metals, what we can say, like cesium and gallium. Their melting points are very much low. They are soft actually. Their melting points are very much low, that when you hold them in your hands, they will melt away. Right? And similarly, non-metals. So whatever the properties we see in the non-metals, that we cannot find that basic properties of metals, like malleability, ductility, sonorous nature, are showing the conductivity of heat and electricity, and at the same time the solid nature, right? These all properties, if at all we see, we cannot see most of these properties in the nonmetals. But anyway, we have few exceptions, like see, all nonmetals are not lustrous, but iodine, vapors of iodine are lustrous, they shine, right? And they are malleable, not malleable. Nonmetals are not at all malleable and not even ductile, means we cannot draw the nonmetals into sheets or wires, right? And see, even if non-metallic solids are present also, they are brittle in nature, right? Means they are not malleable, not ductile. And what we can say is they are brittle. Right? How can we say that they are brittle? Means it's very simple. When we beat the metals with something, some hammer or something, they will adjust themselves to be drawn into very thin sheets. But when you beat the non-metals with something very strong object, they will be just beaten into a powdered mass. Means they'll just break away. Right? So we cannot bend or we cannot make the sheet out of the non-metals. We can just make a powder out of the non-metal. So that is what we can say, the non-metals are basically brittle in nature. And among the non-metals generally they are characterized with that they will not be conducting heat or electricity. But we have one non-metal that which can conduct the electricity, that is graphite. Graphite is the exceptional, right? And all non-metals are either solids or gases. And bromine is only one non-metal liquid, right? Have a look.